we were discussing about various different type of forces last time, and just to take a quick recap, we were talking about normal reaction as one of the mechanical forces, and we saw normal reaction force. Saw this as a type of contact force. Between bodies or body and a surface. In the direction perpendicular to the plane of contact. That was the first thing we understood about normal reaction. Then we also saw that, yes, we will discuss assignment 1 today, don't worry. Okay. We also saw that normal reaction self-adjusts. In value. And of course, it always acts perpendicular to the plane of contact. So, just as a simple example, what I'm saying, suppose this is a block of mass 10 kilograms at rest. Okay. What is the normal reaction here? And in the second case, the same block. Yes, that's correct, Shikhar. Okay. Normal reaction will be taking G as 10. It will be 100 Newton in the first case. Okay. Now in the second case, the same mass of 10 kg. If now I'm applying a force like this on it, I'm applying a force of 50 newtons, but such that the force is at an angle of theta equal to 37 degrees to the horizontal. In this case, what is the acceleration of the block and what is the normal reaction acting? So let's start with a quick discussion of this second example. We'll come to the discussion of assignment 1 very soon, after discussing few examples like this on normal reaction concept. So please tell me the answer of the second part, all of you. Again, take G as 10 meters per second square. And also assume the surface is frictionless. Till we discuss the concept of friction, which will be many lectures later, second chapter of Newton's laws will be friction. So until that time, any surface you have to assume always it is frictionless. Okay, so in this case, the first case, I'm sure all of you understood it already, but I'm just going again. That there are two forces acting on the body, right? Normal reaction and weight, and the acceleration of the body is 0. So net force should be 0. So here, normal reaction should balance mg. Because acceleration is 0, so net force is 0. So the normal reaction is equal to 100 newtons. Now coming to the second case, in this now see what is happening. There's the weight of the object, there's normal reaction. But along with that, now there is also this force which is acting. This force is 50 newtons acting at an angle to the horizontal of 37 degrees. Okay. And we also understand one thing कि यहाँ पे block का acceleration कैसा होगा? It will be in the horizontal direction. So the acceleration, Vaishnavi, not correct. Just use the value cos 37 is 4 by 5. Okay. And the mass of the block we have taken as 10 kg. So this is 100 newtons. Okay. Okay, now let me explain. So what's going to happen here is that the block will accelerate along the floor, that is horizontally. Okay. And normal reactions value will self-adjust to balance vertical forces, that is vertical component of F and the weight. Okay, so this was my point of normal reaction self-adjusting. Okay. We won't see the block moving vertically or at an angle or something like that, because it's resting on the floor and the weight is too much. The weight is 100 newtons. So the weight will make sure that it's resting on the floor as it's sliding. Okay, so hope you people have understood this point that I've written on the side over here. Now, इसके basis पे let us do the analysis further. So we know that the block will accelerate along the floor, along the horizontal. So what we have to do is we have to apply Newton's second law, but in such a way that the acceleration is along the horizontal and the vertical forces are balancing. So next step, what we have to do here is we have to apply this thing, Newton's second law, but in a situation where vertical forces are balanced, okay, and this acceleration is horizontal. Okay. तो उसके लिए अभी क्या करेंगे? Next thing is we will resolve forces along y-axis being vertical and x-axis being So that particular force that we had, जो 50 newtons का था, let's first understand its resolution. It's very simple. You've been doing vector algebra all these days. You'll understand the resolution very easily. So this force that was there, it will now have an x component and a y component. Such that this x component will be 50 cos 37, should be 40 newtons, and the y component will be 50 sin 37, so that will be 30 newtons. Okay, so now what we are saying is that इस body पे the combination of normal reaction weight and this force Now this is equivalent to components of fx and fy. Because this angle was 37 and this was 50 meters. So we can replace this force with the two components. Okay. And we can see that the body is accelerating along the horizontal direction with some unknown acceleration E, which we have to calculate. Okay. And in our system of axis, we have taken the horizontal direction as our x-axis, the vertical direction as our y-axis. So because we have done this, taken horizontal and vertical as x and y axis, so we have resolved the forces along x and y axis. What we discussed over here, that net force is equal to mass into acceleration, we इसको components में divide कर देंगे. So along the x-axis, what is happening is summation of fx, summation of all the x forces should be equal to mass into acceleration. Whereas along the y-axis, summation of forces should be 0. Because the motion is happening only along the x-axis. Now we see along the x-axis there is only one force actually. There is x component of this force. So that should be equal to mass into acceleration. Whereas along the y-axis there is n, there is Fy, and there is mg downwards. So it comes with a minus sign. So this becomes equation 1 and this becomes equation 2. And now by solving equation 1 and 2, we will get the acceleration and we will get the normal reaction. दो चीजें चाहिए थी, normal reaction and acceleration. So we will get the acceleration from equation 1 and we will get the normal reaction from equation 2. So just let me take you through the steps of this again. Okay, so first make sure you are clear with this thing, this point over here. Yeah, we are coming to that. Shikhar, coming to that point. So written this down now. Now see, next thing is this. We want to apply net force is equal to mass into acceleration for this body. Okay. But this body पे, we know that the vertical forces are balanced because it is resting on the floor, whereas the acceleration is horizontal. So that is why we will resolve the forces. Next step, we will resolve the forces along y-axis, which we'll take as vertical, and x-axis, which we'll take as horizontal. So this diagram here is showing you the resolution of the force F into horizontal and vertical components. Is it clear, Shikhar? So यही equation को now we have to apply, but we'll apply it in what way? By taking component algebra. We'll take components of this. So that I've shown in the next step below, how we'll take components. So the other two forces, mg and normal reaction, इनको resolve करने की जरूरत नहीं because they are already along the y-axis, positive y and negative y. But F we have to resolve. So we have resolved the force F into the two components Fx and Fy, or the x component and the y component. And now we can see that. Okay, so how much will the acceleration come as now? You can see that the acceleration will come as, okay, so 40 newtons divided by 10 kg. So the acceleration will come as 4 meters per second square. Correct? Okay. And how much will the normal reaction come as? See, normal reaction will become mg minus the y component of the force. So that is 100 newtons minus 30, so 70. So this is what I meant by saying that normal reaction self-adjusts. क्योंकि हमने force को ऐसा diagonal direction में लगाया है, so that vertical component of force 30 newtons is reducing the amount of pressing between the ground and the body. Earlier the body was pressed against the ground with a force of 100 newtons, which was its weight. But now we are taking away from the weight to a certain extent, because the force that we are applying, that force F is at a diagonal direction. So उसका जो vertical component है 30, that is reducing the contact force between the ground and that particular body. This is what we mean by the self-adjusting nature of normal reaction. It adjusts itself from the value of 100 newtons before we were applying the force to 70 newton now, because we are applying the force in that particular direction. Okay, people, so are both the values clear to all of you? 4 meters per second square acceleration आ जाएगा, and normal reaction कितना आ जाएगा? It will reduce to 70 newtons. Okay, let's move on to the next question, which this time now you will solve. Okay. It's like a continuation of the same type of problem, but with one difference now. So again, we have that 10 kg block. On a smooth horizontal surface. But this time now I'm applying two forces. Newtons. And I'm also applying another force now like this. So the block is initially at rest. On a smooth horizontal surface. At t equal to 0, two forces F1 and F2 start acting simultaneously. F1 is at 37 degrees to the horizontal, and F2 is at 37 degrees to the vertical. So find the block's acceleration and the normal reaction applied by the flow. Take G to be 10. Okay, start this question, people. You should be able to solve this yourself now. You have to just apply the same method that we saw in the question earlier. So what you have to do, you will have to again understand that the block is just moving along the floor. It's not going to move vertically. So vertical forces क्या हो जाने चाहिए, balance हो जाने चाहिए, whereas along the horizontal, the net force will become mass into acceleration. So total there are four forces which are acting: weight, normal reaction, F1 and F2. But F1 and F2 you will have to resolve into components, horizontal components and vertical components. So that's where your vector algebra comes in. So this entire part of Newton's laws of motion is just an application of vector algebra. We will see when we solve the worksheet 1 today also. most of the questions is either vector algebra to find the net force, or it is using something like kinematics, that acceleration is given, so velocity has to be calculated, or displacement has to be calculated, or momentum is given as a function of time, so you have to differentiate it to find the rate of change of momentum, things like that. So everybody got the answer so far? Okay, Ritika, I will just check your answer. So let's just understand these forces. F2 is acting such that it will this angle is 37. So therefore this angle will be 53, with the x-axis. And F1 says that this angle is 37. And of course F1 is 20 newtons. F2 is 25 newtons. Then we have the normal reaction and we have mg. So again, now you can see that F1, if we take x and y axis like this, as vertical and horizontal, and we of course know that the acceleration of the body is horizontal. So F1 कितना हो जाएगा? It will be 20 cos 37 I cap plus 20 sin 37 j cap. So F1 will be 16 I cap plus 12 j cap. Whereas F2 on the other hand will become 25 cos 53 I cap minus 25 sin 53 j cap. So F2 after resolving will become 20 I cap minus 15J. Okay. And mg is of course 100 newtons. So now after resolving the forces, now what we have done is we have replaced F1 with components. So F1's x component is 16 and F1's y component is 12. And similarly F2, breaking it into components, F2's x component is 20 and F2's y component is 15. And the block is having a horizontal acceleration E, which we have to calculate, and a system of axes is, yes, Shikhar, you are correct. So net force is equal to mass into acceleration. This will again be broken into summation Fx will be equal to ma, because there is horizontal acceleration of E, whereas summation Fy should be 0 because vertical forces are balanced. Okay. So this time you can see that, so this is my equation 1, this will become my equation 2. So equation 1 में यहाँ पे क्या आ जाएगा? What is the net force along the x-axis? It is F1's x component plus F2's x component. So this equation will tell me 16 plus 20 is equal to mass, which is 10 into E. So the acceleration will become how much? 3.6 meters per second square horizontal. Whereas the second equation will tell me that vertically कौन से forces act कर रहे हैं. So that you can see the forces acting vertically are normal reaction plus F1's y component minus F2's y component minus mg. That should be 0. So the normal reaction should become mg plus F2's y component minus F1's y component. So it should become 100 plus 15 but minus 12. So the normal reaction will become 103 newtons. Here, one of the forces is pushing it down, no? And the other force is pushing it up. Just look at the whole thing in detail, you will understand. resolved it into components. This is the critical step. After this, it's very easy. But make sure that you have got the angles, the resolution, all this correct. That's where your vector algebra comes in. Oh, yes. Sorry. I made a mistake here. Guys, just make a correction. These will be interchanged. So just a second. So I'm just making the correction in red. So this one will be 15 and this one will be 20. Okay. So these here will be 50. So this will be 3.1. Yeah. And normal reaction will become 108 newtons. So that's where we have to be very careful with the resolution of forces correctly. F2y is negative na beta. Sikar negative to hai. That's why see when we have written it in component form, it's coming with minus 20 na. See over here we have written. And that is why here it's coming with a, here in this equation is coming with minus sign. Yes. Okay, so hope this example is done. Now next, we look at a situation like this. We have a smooth inclined plane, which is at an angle of theta, let's say 30 degrees with the horizontal. And a block is sliding down. So this is now again we want to find the acceleration of the block and the normal reaction. So just take down the problem and I'll explain the forces. Okay, so here first thing you have to understand is that the body will slide down the inclined plane. Okay. Maintaining contact. Okay. So that means the acceleration vector will be parallel to the inclined plane. That is the first thing to understand. And secondly, the normal reaction on the block will be perpendicular to the inclined plane. Okay. So these two things are important to understand. So I'm just showing those as vectors over here. So what we'll understand is that the acceleration vector ऐसा होगा. The acceleration vector will be parallel to the inclined plane. Whereas the normal reaction that will act on the body because of the inclined plane, that will be along this sort of direction. So this is what we'll have to incorporate in our application of Newton's second law. Now, how we'll incorporate, we'll discuss. So as a result of this, so we will take a coordinate frame. No, mg will remain vertical. Mg is because of the earth, no? So that is not changing. So we will take coordinate frame such that x-axis will be parallel to the inclined plane. Along the acceleration vector, and y-axis will be perpendicular to the inclined plane along the normal reaction. So this is what we'll implement to solve the problem. Okay, so next thing, what we'll see here is so what forces are acting on the body? There are two forces. There is weight and there's normal reaction. But normal reaction is acting along this line. And the acceleration vector along this line. Yes, the normal reaction will be at 30 degrees to mg. That is correct. So now, as discussed, what we will do is we will take the direction of normal reaction as our y-axis, and we are taking this direction as our x-axis. So mg has to be resolved. So next step, so while resolving mg, what we'll keep in mind is mg is acting vertically downwards, and in this triangle, this angle is theta. So over here, this angle will become theta. Understanding? So this is something very important to understand, that inclined plane पे if this angle is theta, then when I draw the normal here, this angle becomes theta. So mg को resolve करना है. So when we resolve mg, this component of mg will become how much? Mg cos theta. And this component of mg will become mg sin theta. So mg is resolved into mg cos theta perpendicular to the inclined plane. And mg sin theta parallel to inclined plane. So now again we can see that when we are applying Newton's second law, along the x-axis the acceleration is a, along the y-axis the forces should be balanced. So x-axis के along अब एक ही force है mg sin theta. So mg sin theta should become mass into acceleration. So the acceleration of the body will become g sin theta, which in this case will become 5 meters per second square. And along this direction, the normal reaction should become mg cos theta, which in this case will become 20 into root 3 by 2. So 10 root 3 newtons. Okay. So now again, this is a very standard thing we should understand, that whenever we have a body on an inclined plane, we can divide the weight into two components or resolve the weight into two components. One along the inclined plane and one into the inclined plane, perpendicularly into the inclined plane. So I'm once again emphasizing this resolution is very important. If the inclined plane is at theta to the horizontal, this is like this. So this diagram, if this angle is theta, then this angle becomes theta. So the components of mg become mg cos theta, which is perpendicular to inclined plane, and mg sin theta. So along the inclined, this is okay. So this is a very critical thing in the case of anything moving along a inclined plane. Along the inclined plane. as the same diagram, if the inclined plane is at theta to the horizontal, then the weight of any particle or any body lying on that inclined plane will be at theta to the normal, because this is a right angle triangle, the same as this diagram. So when I break mg into components, this thing, that mg will have a component which is mg cos theta perpendicular to the inclined plane, this component, and it will have a component mg sin theta, that is this one, parallel to the inclined plane. This is the same thing. I just repeated this because it's very important. Okay. Now let's come to a final problem related to normal reaction, and then we will very soon come to the exercise problems. Okay, you can finish writing this first. Okay, coming to the next problem. Okay, so this is a smooth vertical wall, and this is a smooth inclined plane. Now we have, let's say, a cylinder. So a cylinder of mass 5 kg is resting against an inclined plane which is at theta equal to 37 degrees and a wall as shown. So first, show all forces acting on this cylinder in a free body diagram. So I'll explain what free body diagram is. Whenever we make a diagram with the body showing only the forces acting on it, like this diagram over here or the diagram above, like this diagram over here, these are all examples of what we call free body diagram. So we'll write down the definition of free body diagram, but we've been applying it already actually. Okay. And from that, calculate the normal reaction on the cylinder applied by the inclined plane applied by the wall. So before you start this problem, let me explain the term free body diagram again. So in short, we call it FBD. So this is a diagram showing any body as a particle, okay, with all forces acting on it as vector arrows. So, for example, we had that problem earlier today. We had this. Now, इसका जो free body diagram है, वैसा हो जाएगा. We will represent the body with a mass, with a particle, and show all the forces acting on it. So, mg normal reaction F1 this is the free body diagram. Okay, now try out this question. Okay, so let us look at the free body diagram to begin with. So what we have to understand very carefully here is the angles at which the various forces will be acting. So the normal reaction that the wall is applying, let us consider that as N1. That will act along the horizontal direction because this wall is vertical, whereas the normal reaction that this will apply, the inclined plane will apply. That will be in this sort of direction, perpendicular to the inclined plane. Yes, sir. So once again, that concept comes in here that you draw vertical here, this angle will be theta. So you normal reaction as well. And this will be the center of the sphere. So now when we make the free body diagram, the forces acting on it are this normal reaction, which is horizontal, this normal reaction. This is like this, perpendicular to this surface. So because it is perpendicular to this surface, like this, therefore if you drop a vertical over here, it will be at theta to the vertical. And of course, there is mg which is acting vertically downwards. So this is the free body diagram where this angle will be theta. Now you continue from this step. So here acceleration of the body is zero because it is at rest, at equilibrium. So that means net force should be zero. Now the mass was I think 5 kg, right? And the angle was 37. Okay. So M is equal to 5 kg and this angle is 37. So now here we can take this as our x-axis. We can take vertical as our y-axis. The axis will be like this. Okay. So then we have to resolve N2. So next step, that same free body diagram, only one of the forces has to be resolved. That is the normal reaction. N2. N1 is already along our x-axis. So N2 को जब resolve करेंगे, so you want to resolve N2. So the components of N2 will become so now net force is 0. So that means summation Fx should be 0 and summation Fy should be 0. So from our first equation, N1 should balance 3 by 5 N2. And from our second equation, 4 by 5 N2 should balance Mg. Okay. So this will tell me that 4 by 5 N2 is equal to 50, or N2 should be equal to 250 by 4, or N2 should be equal to 62.5 newtons. And then substitute that back over here. So that will tell me that N1 should be equal to 3 by 5 into N2, which is 250 by 4. So that's 150 by 4. Or N1 should be equal to yeah, but that is the previous problem, na Shikhar. There the body was sliding along the inclined plane. Here the body is resting, na? So there is no acceleration vector. Now you can do that also. Then you will have to resolve Mg and N1. So equations will become a little bit more lengthy. Okay, Rahil, so if you take your x and y axis along inclined plane and perpendicular, no, you will get the same thing. you'll get these equations. I'm just writing the equations, you solve them later. If you take x-axis along the incline and y-axis perpendicular to the incline, like this, then you will have to resolve mg. So उसके लिए ये angle theta होगा, and you'll also have to resolve n1, and for n1 this angle will be theta, and n2 will be along this. So if you take x and y axis like that, you'll get equations which are like this, that n2 is equal to n1 sine theta plus mg cos theta, and n1 cos theta is equal to mg sine theta. ये दोनों इक्वेशन आप सॉल्व करोगे तो यू विल गेट द सेम थिंग. Yeah, net force is zero, Shikhar. So the forces along x-axis are balancing. So n1 along the positive x-axis should balance n2 sine 37, which is along the negative x-axis. So n1 is equal to 3 by 5 n2. And similarly, this vertical component n2 sine 37 should balance the weight. Is it clear, Shikhar? Okay, take this down and let's come to the assignment 1 doubts then. So please send me the questions which you have doubts in Newton's laws assignment 1. We will discuss that next. Okay. Question number 7, Rudra. Anybody has a doubt before 7? Okay, Vaishnavi 5 and 11. Anything before 5? Question 1C. Okay. So let's start with question 1C. Okay, I've got your doubts. We'll discuss. So it says that an object experiences an acceleration of 4 meters per second square when a force of F0 is applied to a body of mass, let's say m. So we'll understand that F0 by m is equal to E is equal to 4 meters per second square. Now what the C part is saying is that now B part, actually you have to understand EB. Okay. So this is the E part. Now it says, now if the same force is applied to a different body, its acceleration becomes 8 meters per second square. So if the same force F naught is applied to a mass of, let's say, m prime, then the acceleration becomes 8 meters per second square. So that will tell us that m prime is m by 2, such that F naught by m prime is equal to 8 meters per second square. So now in this C part, what you are doing is you are attaching the mass m with this other mass m prime. You are attaching them together and you are applying the same force F naught. So now how much the acceleration will be? Let's say it's a double prime. So a double prime कितना हो जाएगा? The force divided by the total mass. Okay. So from these two, you can see that it will become F naught by, now m prime is m by 2. So 2/3 of F naught by m. So that will become 8 by 3 or 2.67 meters per second. After this, we will do question 2b part. Anyway, so Ritika, Shikhar, Shravani, is this question clear to all of you people? No, this question 1, B and C. Yeah. Oh, now let's come to the second question, B part. So in that, what is happening? So again, you have on this smooth surface, you have that body. But this time you are applying forces like this. They are both lying in the horizontal plane. And they are like this. Okay. So this is a smooth horizontal plane. So what you do is you understand your smooth horizontal plane is, suppose your xy axis, xy plane. This is your x axis and this is your y axis. Okay. So your vertical axis is your z axis. So इसमें क्या है, mg and normal reaction are balancing each other. So weight is balanced by normal reaction. So now what is happening? The net force, it is the vector sum of this force, let's say F1, and this force, let us say F2. Okay. Which are both in the horizontal plane, which I have taken as my xy plane. Okay. So for the same thing now, if I take what we call the top view, that is, now we are looking into the horizontal plane. So now on that body, what forces are acting? there is two F naught acting like this, and there is F naught acting like this at an angle of 45 degrees. So the net force is the vector sum of this F1 plus F2. Okay, this is my F1, let's say. And this is my F2. Okay. So the magnitude of the net force will become mass into acceleration, and that will be magnitude of F1 plus F2. Okay. So magnitude of F1 plus F2 will become square root of F1 square plus F2 square plus 2 times F1 F2 cos 45. So that will be your mass into acceleration. If you take F naught common here, you will get 5 plus 2 equal to m. So your acceleration should have a magnitude of F naught by m square root of 5 plus 2 root 2. And you do an approximate calculation of this, you will get the answer, which is given. So this is nothing but your triangle law. Okay, people, is the second question B part clear now? Okay, done. So next, let us move on to question number 4. So realize most of these questions are pretty simple actually. Just take some time to get used to them. So question 4 says a single force of 10 Newton acts on a particle of mass m. Particle starts from rest and travels. Okay. So mass of the particle is unknown, but the force of 10 Newtons acts. Only one force. Only the single force acts on it. That means that net force is only F. Okay. So that means the acceleration of the body should be F by m. So it should be 10 by m. Now it's given to us that the displacement of the body is 18 meters in 6 seconds and initial velocity is 0 at t equal to 0. So just use the equation. So you'll get here that 18 is equal to half e into 6 square. So that means 18 is equal to half of the force of 10 newtons divided by whatever the mass was into 36. So from this you can calculate the mass. So it's as simple as that actually. Thoda sa bas you have to connect it with kinematics equation. So many of the questions in this exercise are like that. Pretty simple, but you have to just connect it with these equations. So next I think we have to move on to question number 7. Okay. Question 5, Vaishnavi, okay. Because acceleration हो रहा है ना बेटा, force, when we are applying the force of 10 newtons continuously, the body is having a uniform acceleration. It's saying that a single force of 10 newtons is acting on the body. So it has a continuous acceleration. That's why Shikar. Okay, so let's look at question number 5 before coming to 7. So question 5 is saying is in order to drag a 100 kg log along the ground at constant velocity, we have to pull with a force of 300 newtons. So let's say along, now this is a rough surface. How we know it's a rough surface? Because there is some drag or friction force acting. So in order to pull this at a constant velocity, that means the acceleration should be 0. We are having to apply a force of 300 newtons. Its mass is 100 kg. So it's in spite of applying a force of 300 newtons, okay, if the acceleration is 0, that means there is some kind of drag force on the ground, which is why I said that it's a rough surface. So there is some kind of friction, or what you can also call it, something which is dragging it. Okay. So this is showing you that since the acceleration is 0, it means that F is just balancing friction. So that means the friction is equal to 300 newtons. Now the question is asking you that what force you should exert so that you want the log to accelerate at 2 meters per second. So in the second situation, you want the same log now to accelerate at now you want on the same surface, it should accelerate at 2 meters per second square. So you have to increase this force. You have to make it something f prime is larger, but the drag force acting on it will be the same. Okay, so this will be the same. And that will be 300 newtons. Okay. And the mass of this is 100 kg. So this time your force f prime minus that same drag force should be equal to mass into acceleration. So f prime minus 300 should be equal to mass, which is 100, into acceleration, which is 2. So your force should be increased to 500 newtons. Okay, Vaishnavi, this is clear, beta? Yeah, friction remains the same because friction depends. We will study this at a later stage, but friction does not depend on the horizontal acceleration here. Okay. It depends only on the weight of the body, okay, and the surface. Like the same body on a metallic surface will have different friction compared to the same body placed on a wooden surface or on a marble surface or a glass surface. They will all have different friction. So the material of the surface is what matters and the weight of the object is what matters. Okay. What material the surface is. Okay, so let's come to question 7. Now question 7 is a slightly different type of question. Okay. It is giving you a formula. So given in the question is the formula for acceleration due to gravity g at a height h above the surface of Earth. So if g is equal to g naught at the surface, which we know is around 9.8 meters per second square, whatever, then g at a height h is given to us as g naught upon 1 plus h by r whole square, right? That is the formula which is given to us. But this is the same thing as this thing, where r is the radius of Earth, which is approximately 6,400 kilometers. Must be given in the problem. Yeah, it's given as a more exact value, 6370 kilometers. Okay. Okay, so forget about the pounds part. You don't have to worry about the pounds part so much. Okay. I'll tell you about pounds, but E part on the surface of the Earth, the weight of a person is nothing but mg, but on the surface. Okay. So it will be 80 kg into 9.8 meters per second square. Okay, so that will become how much now? 784 newtons. But this is on the surface of the earth. Now, though it is not necessary, but I'll just tell you, conversion of kg to pounds. Okay. So, 1 pound, okay, this is equal to how much? Let's understand. Okay. So, 1 pound, or you can just understand like this, that 10 pounds is equivalent to the weight of 4.5 kg on Earth's surface. Okay. So, in other words, 1 pound is 4.5 kg into g divided by 10. Or you can say that 1 kg weight, that is 1 kg multiplied by g on the surface of the earth, is equal to 10 upon 4.5 pounds. Okay. Therefore, 80 kg into g naught will become equal to 80 into 10 upon 4.5 pounds. Okay. So that will be approximately 177.78 pounds. So as I told you, this system of pounds is not compulsory for you because it's an outdated system of measurement. 785 it is given because they have taken a more exact value of g. Okay, it doesn't matter, 784 is fine. This is from this value, but g I think they have taken as 9.82. They might have taken. Okay, so from that you will get the weight as 784 point something. So don't worry, 784 is fine. It's all right. Okay. Now let us come to how we'll calculate the weight of the person in newtons at a height of 300 kilometers. So B part, at h equal to 300 kilometers, g will become this. So it will become 9.8 into this. So it's very calculation intensive, but other than that, there's nothing much in the question. So this question is more just to explain to you how acceleration due to gravity hardly changes for even hundreds of kilometers. Only when you go to thousands of kilometers. Okay. And the C part's answer is that mass will be the same. Mass is not affected by altitude. The inertia property is not affected by gravity. Okay, people, can we continue for another 10 minutes or do you have another class at 10:30 or something? Any of you have that college lecture or anything? Or okay. So I want to discuss at least a couple of more questions which are critical. Okay, so 8th question, let's come to that quickly. So is this one clear? Okay. So let's come to 8th question. So that what is happening is you have two blocks which are kept against each other. On a smooth surface. So this one is 2 kg. So let's say this is M1 and this one is M2, which is 1 kilogram. And we start applying a external force. Initially the blocks are at rest and we start applying an external force of 5 newtons like this. Okay. Now I'll just quickly explain to you how the blocks interact. Okay. Now देखो यहाँ से push कर रहे हो, so that means this block will push against this block. So whatever acceleration this has, this will have the same acceleration. They will move together. Okay. So what will happen here is both will move together with common value of acceleration. Okay. Because M1 will push M2. But what it pushes with normal contact force. So when you think of free body diagram, now just to illustrate, I will actually show them like blocks, but ideally a free body diagram should just be shown as a particle, but anyway, it doesn't matter. So M1 and M2. Now here the moment I'm applying this force F on M1, what will happen is, because M1 is against M2, it will start pushing M2 with some normal force, contact force N, and because of action reaction principle, this will be pushing it back with N. So these two, you can see, are in action reaction pair. And of course, apart from this, there is also the vertical forces, but those are balancing. इस पे जितना भी weight लग रहा है, ground इस पे equal and opposite. Normal reaction N1 लगा रहा है, and whatever this one's weight, that is balanced by whatever ground is applying N2. And they are having the common acceleration E. So this is the concept. So now if you look at the free body diagrams, for M1 It's like this. There is F, there is N, okay, and that's creating a horizontal acceleration E. So F minus N is equal to M1E. That becomes our first equation. I'll come to the vertical forces, but right now they're not important. For the M2, there's only one force acting horizontally, and that is this normal reaction. And that is giving it the same acceleration E as the first one. Okay. So N is equal to M2E. That's your second equation. Now solve 1 and 2 and you will get the acceleration. Okay. Of course, along with this, there are the vertical forces also, but they are balancing each other. So whatever weight is getting balanced by N1, and whatever weight is getting balanced by this normal reaction N2. So now solving equation 1 and 2, you will get E as F upon M1 plus M2. So that will come out to be 5 newtons divided by, how much was it? 3. No? So 5 by 3, or approximately 1.67 meters per second square, and you will get N as M2, which is 1 kg into 5 by 3. So N will also approximately come as 1.67, but that is in newtons. And this is the acceleration in meters per second. Okay, so this is the critical point to understand over here. Last two steps, you have this equation, F minus N is equal to M1A. This is for block 1. You can see horizontally two forces are acting. One is positive, one is negative. So, and for the second one, there's only horizontally one equation, one force N. So that is mass into acceleration. Now just add these two equations. So N gets cancelled out. Okay. So your acceleration comes out to be F upon M1 plus M2. So that is 5 by 3. And then substitute this back here in the second equation. So you get the normal reaction. Okay, we'll discuss in the next lecture. I'll just give you a hint of how to do 9th question. Just a couple of minutes. Okay, we'll finish by 10:20. So 9th question, you calculate F1 plus F2 as the net force is equal to mass into acceleration, and then you take magnitude of net force is equal to mass into magnitude of acceleration to find this. Okay. Now this vector sum, this thing, you can do by component algebra, okay, or triangle law, both the things. So 9th question you can do that way. Okay. 10th is also like that. In component algebra it is given to you, so just same for 10th. Okay. Now in couple of questions, 11th and 12th, you have to use differentiation. Question 11 and 12, velocity is given as a function of time. So you have to use kinematics, that acceleration is dv by dt. So it is differentiation of that function. So differentiate with respect to time using calculus. Okay. And from that you calculate acceleration, and from that you calculate force. Okay. And rest you should be able to handle. Question 13, again use kinematics. Use this relation that v square is equal to 2as when u is 0 and acceleration is uniform. So the bullet is passing through the barrel of the gun. The length of the barrel is nothing but s, and v is the speed with which the bullet comes out. So a will give you the acceleration of the bullet as it is passing through the barrel. So what is happening, that there is a chemical combustion reaction happening inside the barrel, which is creating heat and explosive energy. So that is pushing the bullet with a certain average force as it's passing through the barrel. So that is what is creating the acceleration. So as the bullet of the gun is going through the barrel, if we assume it has a uniform acceleration, then its velocity when it comes out should be equal to 2a times s, where s is the length of the barrel. Okay. And question 14 and 15 again are to do with net force by vector algebra. So for question 14 and 15, again calculate net force by vector algebra. Alright, so I think you should be able to complete this without too much difficulty. If you are getting stuck in any other questions in between, just drop me a message, I will help you out. Okay. So that's it for today's lecture, people. I will be sending you a second worksheet also, and we'll discuss that in the next lecture.